and I see how like RDFS is like kind of like the minimum viable like schema definition language, and then OWL is like solving those risks or the limits that are talked about in the last video, about like, you know, you can't model exclusions, or like, you know, like, I don't know, like there's certain limits of what you can really say about RDFS in terms of like, you know, oh, you have to like, each person has two parents and only two parents and like stuff like that. And so I can see how like now we need like, you know, a layer on top of RDFS to kind of like have more more semantic detail using RDFS, but building on top of it. And so I guess that's what OWL is. So that's makes a lot of sense to me, and I'm glad I'm kind of finally starting to see the pieces clicking together. But the one big question I still have, which hopefully he kind of goes into this later, is like, what are the like the actual tools that I can use today to like build things with like RDFS, OWL, and Sparkle? Like, because I feel like a lot of the tools that are out there are really like super old and like just feel like antiquated, and I just like wonder like what's the latest and greatest basically in tooling for the semantic web. And like, because I want to start using it, right? Like I want to start playing with it, but I also don't know where to start because there's so many different pieces, and maybe they all have different tools, or maybe there's one tool to rule them all. I have no idea.
Yeah.
Yeah, I like the videos.
And Marmota is like archived, but it was kind of like one of my favorite semantic web tools. You know, like it's almost been. I don't know if this is true or if it like went somewhere with Neo4j or something with the graph database, but it kind of seemed like maybe early 2010s that there was a lot of buzz about the semantic web, especially in the research community, but then like it didn't really get adopted a lot from like outside of that community. So then things kind of stagnated and kind of dried up a bit. But I don't know if that's the truth. Maybe it's reincarnating somewhere else, and there are some flashy tools somewhere. You know, it is. Some developers, they're trying to make money and just like learning new things and adding new things to their product when they're already making money, you know, and things seem rosy. Then it's just like, I don't know. But like, I'm just speaking out of the air. I don't know. Maybe there is something somewhere. You know.
Is it? I wonder if it really is just like semantic. Or I'm sorry. I wonder if it really is just incentives, like, because I don't know. Like, why was if there was like no other ones that were as good? Like that seems crazy to me.
Oh, then what you mentioned, like the Virtuoso and the Apache Jenna and Lego Graph and.
Oh yeah, I don't know. Look into those.
Yeah, you have all the examples. Yeah, I like Marmota because it has a sparkle endpoint, and it like you can click on things in your query, and it'll kind of adapt it over time, kind of thing. So you actually could through the GUI you can do some pretty complex queries, but not actually think about what you're doing.
That sounds great.
But in my research, there's a lot of other ways to access RDF type data other than just the Sparkle endpoint. Problems with the Sparkle endpoint is you kind of have to know what you're looking for and know what the RDF graph looks like. Not only, I mean, and then like the other problem we talked about the other day is like trying to get people to put data in there. and the burdensome, and just like why, and then beyond that, um, which I don't know. Maybe my hope is maybe the content addressed world will help a little bit because in the content addressed world you have a little maybe more persistent data because it used to. I don't know. Maybe not because it used to be you'd be referencing all these ontologies and these namespaces. So well, and like the URI would just go down, or you'll you even have the problem where I'm in the process of sending the book back, but there was the like that $70-$80 book or more, which is kind of a handbook for the semantic web. It goes through like all the tools that they developed over the years. Well, not all of them, but a lot of them, and some of them that kind of made things easier to search, like Swoogle, which was from the University of Maryland, I think, or Falcons, which I guess was out of China, which allowed you to search for different like ontologies and terms and stuff. I don't know if those really exist anymore. Like at least Falcons doesn't. So like, and like so like the vision of the semantic web is to have this giant kind of global graph and metadata, and you can search everywhere, and like, and it was going that way, but you know you have the problem of expressivity amongst a heterogeneous group, the world, but also the burden of like putting the structured data in, and so but like I don't know if it could happen again, or like if we could potentially play a part with we have better maybe well, I mean like the theory's been around for a while, but maybe there's better machine learning or AI kind of tools around now, or maybe this content address way of looking at the world could help. You know, I mean, that's what I've been drawing on, but you know, maybe it make it better. That's like I'm at this point where I'm still curious, and I still kind of want it to exist, but I know I can only play a small part to make it exist. But like, you know, what can I dig into? Hi, Jason. How did you feel about the readings? we kind of went on a tangent, so but
they were really hard for me to like follow for the most part, but then they kind of clicked and made a bit more sense what the RDF structure really is about, what the just the structure is there, because I think it was alluded to last time, but it's just like JSON LD, essentially, just their representation as XML in this course, it seems.
Yeah, JSON LD, I guess, is a serialization of RDF. But like RDF XML is another serialization, so is Turtle, so is N3. Although, I don't know, I mean, JSON LD was kind of developed by Manu Swarni and Digital Bazaar and other people because I thought a lot of developers use JSON, and they wanted to just like add context and maybe ID property to it. I forget, you'd have to read this back what the difference is, but like to allow ways to get in there. And there's converters between those different serializations that you can do, because like RDF XML, for example, is like not really very readable. Turtle is, JSON LD kind of is. It's kind of the middle ground, but it's also usable to more. The syntax is more understandable, more familiar.
That makes me think of that makes me think of like all these different serializations of, you know, RDF, that you mentioned, it makes me think of how IPLD approaches that by having a single data model and then having codecs for all the different serializations of what that data model could look like. So whether that's JSON or it's what's it called, CBOR, or like some specific blockchain transaction or whatever. Like ultimately, they all kind of share the same data types. So if you have one data model that is generic enough to describe them all, then you can have like almost like a plug-in ecosystem of different like converters or translators from the data model into whatever the other serializations are. So I wonder if something like that exists for RDF, because then that would make JSON LD, Turtle, M3, like whatever you use, like it doesn't matter as much anymore, and it makes it more of like an implementation detail rather than something you have to like think about or develop for. I don't know if that exists, but it would be really cool if it did.
You mean just to translate between the serializations on the fly?
Yeah. Like if you have one app or one ecosystem that uses like JSON LD, or you have another one that uses, I don't know, they're like whatever the other ones are, then you just have to write it once, and then the application developers can basically use the corresponding converter or codec or whatever to translate it into their serialization.
Well, I've been going through the did IPNS project. They have a universal resolver in it that does something similar to what you're talking about, where it looks across DAG PB, DAG JSON, and DAG CBOR, and is a universal resolver across those. But I don't know, there probably is at this point for RDF a universal resolver across XML and JSON. If not, seems like something that is fairly straightforward to build and hopefully be open sourced.
Yeah.
Oh boy. Here's a guy. Alright.
That it. Easy RDF.
Yeah, well there's another one developed by... Oh, okay, he's at the University of Ghent. Let me see.
PHP is just so good at XML.
PHP is?
Yeah. Like I used to process XML all day long for a recruiting company in PHP, and it was so easy then. That was PHP 4.
Okay. I've never used PHP that much.
The new syntax confuses me, but...
What's the latest PHP? I feel like there was something in PHP recently, like within the last 5 years, or something that kind of brought it back into the zeitgeist, like a framework or something. I can't remember.
They all fell apart after PHP 6. All the devs, they like had huge disagreements, and I think PHP 6 was released and then on-released, essentially, because it was such a junk. But they're on 8 now, and the latest release was today.
Oh, nice. Laravel, that's the PHP framework.
Yeah, that was insanely popular, but then it lost a lot of interest during that.
Really?
Just because of the PHP uncertainty.
Oh, wow. One of the things that we talked about before you joined was, I was kind of asking the question, like, what's the latest and greatest in tooling to interact with all these things? Like, right, like RDF, RDFS, the schema language, and then like, OWL to kind of like on top of the schema language, and then, like, I don't know, there's like all these different pieces, and so I'm like wondering what the latest and greatest is, and it seems like everything's like been either sunset or abandoned or retired, or if it does exist, it's like so old that it feels like you're in Windows 98 or something. Like,
There's
I,
such a huge amount of churn in software packaging.
I know, it's sad. But if there's not tooling, it's like, well, I guess I have to build tooling for this. Like, I don't want to have to do that, but
Yeah, I dumped some tooling there. I mean, it just, I think I should be able to dump a lot of links for a while because my brain's a huge repository of random information. Just have to hit it with the right query keywords, and eventually and then I'll search for things, and eventually I'll be able to dig it out. So that's what I did for the JavaScript implementation. I just remembered a few facts about it and that allowed me to discover more facts and more extracts of things that I have been familiar with for a time. But like, yeah. So I think there is kind of tooling, or either there's mothballed tooling that I know about because I've known about this space for a dozen years, or there's something more current. Just like it's just a matter of digging for it, I guess. But yeah, I can go through like lots of stuff that I have written down over the years and just query it, but it just might, since I haven't touched it in a while, it might take me a few minutes to bring it up, but yeah.
I thought all of the stuff in the Sparkle portion was interesting. Or sorry, actually, the Triple Store episode or whatever was interesting because it seems like there's a lot of considerations and trade-offs and constraints that you have to consider with a triple store, like especially in terms of like if you want to, I don't know, make like if you have a ton of data, or if you just like want to optimize for certain like queries or indexes or whatever. It seems like those trade-offs feel pretty jagged. I don't know, like I don't fully understand it, but it seems like it's definitely not as, dialed in and cut and dry as like, obviously just plain old relational databases.
Yeah.
So I'm curious to see how difficult it is to have, a queryable triple store, especially considering like content addressing and all that kind of stuff. Like if I want to be able to access, a subgraph or whatever,
Right.
in IPFS, for instance, that's content addressed. Like I wonder how that can be stored in triple stores, like distributed and
Yeah, that's the thing.
yeah.
If you have a Sparkle endpoint, it might be on a single server or like cloud server, some install somewhere. But like sometimes you might want to look about like, oh, I want to merge data on this server with data on this server and find out commonalities, or like do a graph, find out more information and glean more detail, and that's like valuable, but it's like not easy if you're having to federate. Yes, although there's been some work to do that, but bringing it over to the content address world, I don't know. That's why I was like, I guess this is an exercise we'll have to do. And like, I was trying to reach out to Mauve. It was in our group, but then the problem was, I don't know, maybe hypothetical, maybe this would have been easier a couple of years ago, but like the cost of living is so high that they're having to do like a lot of side gigs, and they're really having to watch their time. And like, so basically the long and short of it is it's kind of an effort on me or other people who are like interested in pursuing that and condensing something down and like paying them for like $120, $180 an hour to just look over it, because that's their they're going right at the co-op, and
Yeah.
like, although, you know, it might be more or less because it looked like some of the stuff we were working on might have reuse in some of their work. So, I mean, but I mean, the long and short of it is they got their expenses. Everybody has their expenses, and like, so they were suggesting, oh, why don't you talk to the Ethereum Foundation? Or that actually reminds me, I should put a link to this one post of this one organization. I think it closes out today, and I was it seemed similar to what the ISIP thing, and like they were actually sponsoring people, like financially. So, I mean, they're like, not that I'm like necessarily trying to get rich, but you gotta bring money in. I mean, the big goal is to like, how do you keep the thing running and get the expertise in that you want to have to ask questions, right? And to build the thing out, and so that's what Mauve put out. And let me see, there might be some other. Oh dear, where does the message go? Oh, I guess that's the big thing, because there was Ethereum Foundation, and there was one other organization that began with an I. But my Discord's misbehaving, and I can't access it right now. Access the message right now. But I don't know. Let's see if that thing, and that also gave me an idea of, like, I think it closes out today. So if that doesn't actually have an overlap, he's looking for a collaborator. And also, I guess we have till midnight, I guess, tonight, Eastern time, to submit an application there. And I might do that just to, try to make sure this thing stays rolling.
Yeah, I've seen summer protocols. I've heard about people participating. I might have to wait till because I feel like I'm still kind of dialing what it is.
Yeah. So yeah,
like,
I mean,
it's difficult because like the vision.
I mean, I guess
the vision is so like all-encompassing that it's kind of
the vision
difficult
of theirs?
to like.
ISIP or summer protocols?
No, of my own.
Yeah, I have that thing too.
No,
it's fun.
Like, I don't know, and also what Jeremy is working on.
Yeah.
Like, I think they all like coincide, and I guess like the answer to me is like maybe finding the common layers and the common, like, solutions and libraries, things that need to be built in order to enable all of them, right? And then put together proposals for funding for those pieces as part of a larger thing, to kind of feed two birds with one scone.
Yeah. So, yeah, this would be good. I mean, like, this is a good thing and a bad. It's like we said, Fission shut down because they couldn't get enough funding. I guess they were doing really good research.
Right.
But again, if we say we can solve breaking it down and solving the funding problem, then actually that could help them too, because I think they're still eager to wanting to work on it. I mean, just that they just have to have a way to have their necessities met, So it was like we trying to solve this problem is actually helping other people too. So
that blows my mind that Fission couldn't find funding. Like, I almost don't believe it. You know what I mean? Like,
yeah, because they were such a dominant force in the space, right? So well.
Yeah, and they're obviously producing
niche, right?
results. So like,
I almost take it on myself as like, oh, I wasn't building fast enough for their tools, and then like their funders thought, oh, you don't have enough projects that we know about, we'll pull the
Yeah.
funding, and like so, yeah. Huh. And I don't know. I guess they did make the choice of not really doing hackathons, and they're just like you're doing R&D and just I think hoping that other people like NFT storage, Web3 storage, and maybe Blue Sky or who else, I don't know, were using their standards, and like that was enough. But I do kind of remember them being asked about what their business model was, and then like I don't know, I can't speak for Boris, but I guess for Brooklyn maybe it was like, oh yeah, we're very hopeful, and they like weren't, it wasn't that concrete sort of thing, but it was like, but I guess some people were just like I guess that musician guy who did RubyConf or something. I don't know. But anyways, they threw a bunch of money at it at some point, but I don't know why they just decided, oh, we're not going to do this anymore. Maybe it wasn't growing as fast as they thought, or in the way they thought. Who knows? Although it was odd. It was like creating value for the community. People liked it, what they're doing, but it wasn't, that value wasn't coming back enough to them fast enough in dollars somehow, which was odd. I mean, and then they were coming out with IPFS, and they were about to IPVM, and they were about thinking, and it was going to be a really cool thing where you have the hashes. And not only, but they're actually like compute. You can compute with the hashes instead of like having it be static, and in the IPFS, right. And like that was really cool. And it sounded like they were like in beta where it was going to be free, but then they were going to have people use it, and then they're going to have a payment layer on top of it. But then it just disappeared. It decided that, well, we still want to have a community, but we're looking for work now. This is odd.
Well, they're still working on UCAN and IPVM as their own kind of like projects, but it's just not under the umbrella of Fission anymore,
is
right?
That what they're... Yeah, I don't know. Brooklyn said she was going to do UCANs at least. I'll have to quote it, but I hope IPVM. I mean, that was really cool. I like that, and I mean, if there's a way, I'd still like to use that in my project, even if it goes open source and like,
Have you heard of Bacala? I'm mispronouncing it. Oh,
Could you drop a link?
I'm spelling. Yeah, they were part of Protocol Labs, and that was the original compute over data from them.
Oh, okay. And they're still a thing?
Yes, just found the link.
Nice.
But I think IPVM was kind of an extension of that research because Bacala was, I guess, nucleated maybe? I'm not sure if it was before nucleation or not, but they are their own entity now.
Interesting. I guess I don't have like a good mental model of like what compute over data enables. Like, I was trying to read up on the IPVM stuff, and it seemed pretty cool. Like, I guess my understanding is that you can like reuse functions so that you kind of like in the same way that like content addressing can uh, reduce redundancies in data storage, compute over data, or I guess like content address functions, which is what I think IPVM was like focusing on, was like reducing redundancies in compute. But I don't. That's about the cap of my understanding. So I'm really curious to hear like what you guys think of compute over data and what it enables, IPVM or even Backel how or whatever they're doing.
For me, the goal of compute over data is to be able to ship like a WASM or some other compiled binary to where the data is and where I need to process it. So if I'm training an LLM and I've got a data center of storage machines, I can push out a WASM to those machines and they train on the data that's on them and then come back and compile all the LLM vectors into one big model.
Yeah, from an infrastructure standpoint, it is really useful for if you're building up a data center, as opposed to having to have like a dedicated server. You could have like a general cluster, and you don't have to run like a lot of software on top of it to just run the compute modules themselves. In fact, the virtualization gets even easier. The scalability basically becomes like a compute module. And you can basically like create dedicated like appliance like architecture or infrastructure. You can actually use the same model that you use for Bitcoin mining, where the full stack of a unit is just shoved into a single compute module. You plug it in, you give it an IP address, you give it a UUID for its own unique identifier, and you throw it on a pool, and it just gobbles data day in and day out, spits out data day in day out, and then occurs revenue that way.
So it's just a way of distributing compute so that it's like not client server where there's like a single server, but it's more like there's an arbitrary amount of servers so that you can compute faster and more efficiently. Is that kind of?
There's a bunch of different use cases, but yeah,
Okay.
I mean, it's more efficient. So the arbitrage problem with current server architecture is large enough burden that it takes like large dev teams to handle the management of large software infrastructure. So you just think about it from like the number of devs you require to do a task, and to set it up and to run it. Like just imagine like how much effort it would take you to bootstrap your own like Web 2.0 widget if you wanted to go build a data center, build a cluster, build the infrastructure on the internet, build the Linux architecture, build the server infrastructure, the dev infrastructure, everything to stack on top of each other, the networking, and then have to host users, and like do load balancing and all that,
Right.
and all the other tasks that have to go on top of that. When in a lot of these cases, all you need is distributed compute, and you need to be able to like throw your compute onto a network and answer an Oracle style answer back onto what the answer is, and then your program is locally handling it, and it has enough smarts to be able to handle the compute aspect of it. But you want to offload a lot of that compute to the cloud, and to do that seamlessly is a open problem still.
And this whole architecture is extremely contrarian to what has been done and what has been successful, so it's very hard to get people to buy into it, even though on paper and in theory it's all very much better and can pretty much be proven through nature.
These are better for like greenfield projects that don't have any legacy support or legacy application. But there's not been, except for AI, and AI is taking down AI unfortunately is taking down trucking down the path of centralized existing hardware and architecture, because that's what it was built on initially. But the moment somebody comes up with a way of like easily translating AI models to like IPVM, I think you'll see a lot more uptake on IPVM.
Yeah. I mean, there's certainly political reasons um, for a slowness of adoption, because corporations and powers that be want to maintain control over compute, um, and this would essentially decentralize that in some capacity. So I imagine that's probably a big factor as well.
Yeah, it definitely disrupts those big Web2 market players, even though
Mm-hmm.
they like Ethereum is basically Amazon. So Amazon is a huge supporter of it, basically.
Yeah.
Um, but there's that big fear in the corporation of this technology enables so much of just regular folks. Um, there is a Kosh out there. I haven't looked too much into like the technical side of everything, but you can run VMs and everything inside of their network. It's WASM VMs, not like VMware VMs, but they've been around for quite a while, and they have a token and everything, and they support GPUs, and I think they even support networking in some capacity now, which is quite difficult for like a workload that you're decentralizing to access network.
Yeah, I'm also looking at setting up like a micro server or a data center. I've got a business that needs like 1 to 5 gig symmetric up down and a rack installation. So I may have like a rack for like a experimental pizza box to be shoved into. Yeah, if somebody has a good use case for it.
Wait, can you explain that one more time, like what it is? And
I'm getting quotes right now from AT&T for fiber installed to it for a local business. Um, and I'm looking at installing a rack and like a fiber access. And I've got at least a couple people that are interested in putting in like file data backups and stuff like that. But if you can think of a good use
oh, I
case
see.
for like shoving on a like an IPVM or IPVS, like a local node, um, that I'd be interested in setting something like that up
Okay.
or entertaining that at least.
Yeah, I'm getting close to needing to research that stuff.
Yeah, but it's one of those things where it's like the price point doesn't make any sense unless you've got like a bunch of people all using it for an application, and then it makes a lot more sense.
Right. I was talking to this one guy a while ago who was working on kind of like a super user friendly like um, server box that's like just vanilla ready to go, that anybody can just like plug in, install whatever they want on it, and yeah, basically just making it much simpler for people to run their own stuff out of their house, without having to do all this research to go find like the right kind of server, or if you need like, you know, RAID storage for like a NAS or like all this kind of stuff. Like it, I guess it's, yeah, just making it a lot easier. And I'm thinking that'd be really nice for the future of like this kind of like distributed compute, because people who aren't like super technical but like just technical enough to follow a tutorial can like, you know, do their part in maintaining the network by just like running a nice like open source hardware and software box kind of thing. I
That
wonder
might
if
be
there's anything out there.
well, that might be interesting. I've got I hook up with like a steady stream of like end of life servers and
Mm-hmm.
like electronics hardware. So like if there's like a use case for like because most when they do like server decommissions they strip out the hard drives, but RAM, motherboards, processors, chassis, power supplies are all usually still in there. So like a small like image and compute file on a SSD, and shoving that into like a box and then shoving that back on the network might be really interesting. Because usually the really biggest problem right now in recycling and like in resource distribution is arbitrage on resource allocation. Essentially, like the middleman problem of like I have resources, somebody else has a need. How do you communicate those back and forth to somebody without like having like a horde of middlemen running back and forth, being like, "What do you need? What do you need? What do you need?" So
Right, like connecting people directly to each other in a network.
yeah, I could see IPVM and IPPS and Filecoin and stuff like that being instrumental in solving some of those problems. The one problem I don't like about some of them is that sometimes with the coin approach, there's a lot of like rent seeking in the form of like free allocating tokens. And so I'd prefer a coin that or a system that is purely based on usage, as opposed to trying to basically add on top of that a investment approach.
Yeah, like staking and all that.
Yeah, because all it does that distracts from the actual use case. But anyways, that's where I'm interested in.
Yeah, I agree there. USDC and cash.
Yeah.
Did anybody see the NFT storage announcement? You mentioned Filecoin.
No, I've not been really catching up with the news. What's going on?
They are transitioning June sometime to just be a Filecoin penning provider. So whenever you submit a NFT to their system, which it has to be a legitimate NFT now, like on an Ethereum or Solana or Near chain, and it's just going to upload it to Filecoin. And
So
it's up to
IPFS or anything else like Arweave or
no IPFS, no Arweave. It's just persistent to Filecoin, and you can retrieve it through their gateway.
you.
But you already have to have it on IPFS in the first place to get it stored there. So the price is $2.99 per gig for long term, which I hope that means 20 years. Which if you've generated an NFT and you don't want to appear like a rug pull, that's a fairly low cost to pay.
Yeah.
Protocol Labs has been around for a while. I suspect NFT.storage will keep its files online some way or the other for a while.
But like restricting it through a Filecoin gateway or whatever, like that feels not great, like a point of centralization, right? Or maybe not. Maybe I'm misunderstanding the architecture.
Once you put your data onto there, you are able to fetch the Filecoin deal IDs. So after it's done that, you could technically go and fetch the data off Filecoin yourself. But yeah, that's crypto storage. There's lots of gotchas in all corners.
Right. Yeah, I don't understand why people don't just use Arweave. Like, I feel like they've solved the problem, like way long ago. Because their whole, like, endowment model, it's, like, so cheap to store anything on there. And it's permanent. Like, I don't even think... Like, basically, I think they basically say that by the time... it won't by the time you need to worry about it, like we'll as a species we'll have like ways to store things that are like like storing things in DNA or whatever. I don't know, but they basically are saying like actually permanent, like can't, like it's definitely projection out way far into the future in terms of worrying about if it's going to be stored or not.
How are they doing cold storage?
What?
How are they doing cold storage? Because I
So the way the Arweave endowment works is it's a fund set up by your file that you're storing, and it pays the storage providers Arweave, and it will the smart contract is able to automatically run on its own, and it knows when your file's like losing redundancy, and is able to pay other providers to bump it up. The theory is that it'll last 200 years. Those files on it.
That's what it is, yeah.
I mean, that sounds like that's ripe for like manipulation though. Like if you can find a way of if you can find a novel way to manipulate the storage requirements, you could like suck the value out of it pretty easily. Very similar to how recently we've had I think in Oklahoma at least, they started legislating against or doing an investigation about price fixing for oil and natural gas, because we had a couple of cold snaps, I think last year or the year before, and they're looking at basically when you have a resource crunch and you have a run on a particular resource, a lot of the rules come into play with price gouging. I'm curious whether or not there's a similar case to be made for data uptime and price gouging in terms of availability. So like if you had a temporary network spike or network downtime, and if you had the network down long enough, you could basically force the algorithm to prematurely optimize for more storage allocation at an exaggerated rate. And then when it comes back online, the contract's already been drained out. I'm just curious how they handle some of the history books of fraud that are out there to learn from.
I think the transaction speed of the main chain is so low that's not a super concern.
Okay.
But it's similar to your concern. What has happened is they've had spin-offs of their layer 2 that want to spin off their own layer 1. So I think there's a whole different Arweave out there right now that's the kind of popular one amongst the VCs and everything. That the big L2 that was doing bundling onto Arweave switched onto themselves.
Oh,
So
really?
it caused a lot of they're both still around, but it's only been like a year now. So it's kind of like, is a fork going to win, and is that fork going to continue serving data from the previous fork that it came from?
Yes, the mutually assured destruction of the open source world. Everyone's free to fork off, but it's not guaranteed that people will come join you.
Right. I'm really interested in my personal want for crypto coins is one that's just for cold backup archival, just jams it on a tape, and I've paid for it, and I'm done with it. You keep it on that tape,
And then they ship you the tape, or they keep it somewhere?
their job is just to keep it somewhere for like the very rainy day, and then I have to pay them a lot of crypto, and they get it out, just like I'd have to pay Amazon a lot of US dollars to pull out of Glacier.
Yeah. I mean, I think that would. I mean, well, that Glacier and things like Glacier are very profitable from if you do it in scale, are very profitable from a archival standpoint, because the data bit rate is low enough that if you do it in aggregate, it's not too bad. The biggest, and as you already know, the biggest issues are the ingress and egress of data from a system like that.
What is ingress and egress?
Egress is exiting, and ingress is entering.
Bandwidth related.
Oh, okay.
And Amazon will eat your bills just for like operations, just for moving things from regular to Glacier.
Yeah.
So
I mean,
really
it
hard platform to watch your cost on.
And it does make sense. Like the biggest cost is on data transfer for tape is writing to tape and reading from tape.
Yes.
That's one of the reasons why I think tape is non-ideal. I've been really interested, like Microsoft has been getting into it, and some of the audio or video industries have gotten into like optical storage. And optical storage has a nice property where writes are expensive, but reads are fairly cheap. Because the read operation, if you scale it up, could essentially be like you could scale you could build a machine that could read the whole thing all at once using tomography and other optical techniques. So you could read like terabytes or petabytes of data at a time, but writing would be as slow as etching into the silicon or the quartz crystal 1 bit at a time. But
Is that because the optical, you can basically connect it straight to fiber out the way that they read it? Essentially an analog computer.
So normally, I mean, the reason why you can read it out fast is because most of there's optical technique, you can technically read it in as just as fast as you read it out. But because the use case for reading in at high speeds is not as high, it's harder to verify and course correct. Like if you need to read out at high speeds, you can do data correction or you can do multiple reads. Where when you read in, you're physically etching into the media, and so you only get one shot at that. So normally, the write times for something like that are inherently slower. But it's one of those technologies that it makes a lot of sense for like long-term data storage and archival usage, especially considering that we're entering into like a data apocalypse where, like if you look at like just media bit rot that you use on a daily basis, like we don't have. And you think about every age has had like its epochs where like data storage gets more expensive, and so you lose context. But if you think about the like historical, like the reasons why for example, reasons why Plato and Aristotle have survived, like I want to say at least 10,000 years, 8,000 years, something crazy like that, is because of the longevity of the media and the value of the data. Whereas we today don't really have a way of storing high value data in a way that has a long life longevity to it. Like we can write on paper, we can write on, I mean, even CDs and DVDs and tape, they're not 2,000 year durable. Makes sense.
I heard that 3 episodes of Nova are just gone. Like the company that made Nova has been gone for a long time, and they had restricted licenses on them.
Yep.
And nobody has the tapes.
Yep. You can, and actually that's a problem with copyright right now. There's probably a very legitimate case to say that the copyright length is too long, primarily because for data copying and distribution, the likelihood of a technology being able to be around long enough to keep that data relevant to the public culture is not sufficient.
Yeah,
and really,
definitely be in support for a much shorter copyright length.
Yeah. And if you think about it, like, I mean, best case example is like memes from the 90s.
Yes.
I mean, can you think about like how well memes aged? Like it's kind of funny if you go back and look at older memes, and like try to compare older memes to current memes, and like they have like a flair of nostalgia to them, which is weird to think about. Because this is just the beginning of like classic golden oldie memes. But the same kind of concept of like data rot is kind of like is going to be bigger and bigger, I think, as the value of LLMs are basically like data munching machines, and once you've generated them, the value of that data that's been ingested is massive. So long-term preservation of like high quality data sets and high quality like media sets, I think there's going to be more of an issue. As we start trying to basically like encapsulate the value of the 20th century, and then try to turn that into models to feed in the 21st century.
Have you guys heard at all about the kind of breakthroughs and things in storing long-term storage in DNA?
Yes, but DNA also has its own problem.
Well, yeah, but like the idea that, I mean, well, the amount of information that's stored in our DNA is like gargantuan. Like we talk about all these problems of like data storage and archival storage and all this kind of stuff, but like we literally have like self-replicating like data storage in us that has like that stores more data than like all the data that's currently stored like in like our bodies, and it's so replicated and so redundant that like there's like no concern about it like kind of like, you know, not being accessible essentially. And so like these people have been like figuring out a way to kind of like use these pairs of you know, like whatever, cytosine, guanine, you know, whatever, and using it like a typewriter almost, or a typesetting, and they put the entire works of Shakespeare in like the tiniest little bit of DNA, and then, but the problem is it has destructive reads, so you have to create a bunch of different versions of it. But I imagine a world definitely in the future where like people have their own little like, you know, DNA storage stuff with like long-term data on it, and even like societies like storing information and data, and then even a step further, which is crazy and pretty like philosophical and existential, and even like to think about what information is in our DNA right now and what have we yet to discover, because like we could essentially create beings that like kind of inject DNA storage so that like, I don't know, living things are walking around or exist that are basically like living self-replicating data storage. It's kind of crazy.
Oh. It is where we cross the divide to digital or to organic computing.
Yeah.
So
totally.
We need to print the data into DNA so that we can have organic computers parse it and all that, and that's
so
some are very useful. But
there's a couple science fiction books that I don't know if you've read them, but kind of touch on this idea. Dune has a lot of that. The Dune series, if you read between the lines, has a lot of that built into the underlying like reasoning of like how things work. A lot of the mysticism and like past lives part read into. They've got DNA storage, and they've just had it in their DNA for like 10,000 years. Nobody realized that what it was, or they forgot what like the use case of it, and it's just been kind of running amok for the last 10,000 years. The other one is the Hyperion Cantos.
Yeah, I haven't read it, but I've heard good things.
Yeah, one of the scenes in there, they basically have like the sum of all human knowledge in like a biological compute system, and what one of the characters does is that one of the characters was essentially a human preserve survivor. Like all of humanity basically self-immolates, and like the only people left are from this small little human preserve on Earth. Because that's what you do when transhumanism arrives and everybody uploads. But one of the scenes was that he basically like dipped himself into like what would essentially be a CRISPR tank, and has like a large portion of his DNA right appended to, and then gains a good chunk of human knowledge that way.
That's crazy.
We're gonna look back at CRISPR like it's a telephone. It's gonna
Yeah,
be so revolutionary.
I
I
know.
think it is.
It's pretty wild.
Yeah,
I think CRISPR. I think I mean, they're talking about using CRISPR to eradicate HIV, hepatitis, like chickenpox, like Ebola, like any virus that like right appends itself into the cells of your body, like using CRISPR to go in there and like rip it out, like selectively rip it out. Like that is a game changer in terms of treatment.
Yeah, and then applying AI to that to kind of like identify through like brute force attempts, like I like to see like new types of diseases and things to and also to make sure that what they're ripping out is like, you know, discrete and not like, because one concern I have with that is we live in a predominantly left brain culture that's like hyper rationalist and thinks that they can understand the picture by just taking one piece and looking at like it's just a mechanism. But work
I think broke up.
Yeah, but I would agree that I think the genesis of what you're saying. Oh, okay, I'm gonna synthesize and say that yes, the like humanity is not really good at like large scale like interdependency thinking, and that we get kind of like bogged down in trying to think that we can simplify everything to like small component pieces. But in a lot of multidimensional, multivariable systems, like DNA, like biology, like the economy, um, like ecosystems, that rationale and thinking breaks down because we get stuck in like local minimum problem sets without really thinking about the total rationale of what your actions will unfold.
right.
On the other hand, this week, I think I saw it in the news. A person in the United States received a kidney transplant from a pig, and it
Oh,
was
yeah.
genetically engineered to not carry the viruses and everything, and to be a little bit more human friendly. And like the guy's life sounded awful. Like dialysis on its own is not fun, and this guy was having infections every 2 weeks and having to have like ports removed and reinstalled. So um, it was very much a blessing for him because without the like ability to choose what medical procedures he gets when he's terminally ill, he couldn't have gotten that, and without CRISPR, wouldn't have even been like close to an option.
Right.
Like I think
I feel like
we'll
if
learn a
I
lot from the people that
knew
are
that
at
I
the
had,
end.
oh yeah, I was gonna say if I pig,
I think echoed into the digital world again.
Mm-mm.
did I cut out?
Yeah, it was cutting out
Oh,
for about 10 seconds maybe.
oh. I was just saying if I had like a pig organ in me, I feel like I would never be able to forget it, and it would just like always perpetually be on my mind. It's so weird.
Yeah,
I think I got to take off. But it was a great conversation, as always. See y'all next Friday.
Great talking to everyone. I think we're pretty much finished up here, so I'm gonna jump off as well and do some chores.
Right. Thanks.
See ya.
See you guys.